There we are.
Why does that happen all the time? That is so confusing with this system, dude. It's
all the little windows.
The motif versus the short, but you're using motif to do it. Like, I don't know why it won't. Dude, it's my mind. And we have to still fix the other problem too, which I think you should be able to use the eCam mic on the other side of that.
Okay.
Anyway, let me see where we are here. Yeah. All right. Just got to get my bearings straight here. All right. So I'm live. You're live. Everybody can see us.
Yep.
All right. I'm back here. Okay. So everybody can see us. Hello, everybody. All right. We're going to have a good week. I thought I was traveling on Thursday. I'm not. So we'll do our regular show on Thursday. Let's go through our notes, see where we left off. I know we had the agent working.
We did.
So we had a basic agent running. I got to bring the whole system up. Let's look at our notes, and then I'll share some things I was looking at yesterday too, which sort of bummed me out. But all right, let me switch over to this right here. So if I go back to our cap notes, why is this here? Okay, so oh yeah, we were getting this encryption message thing too long, so we're gonna have to write a hack program to figure out what's going on there. Worst case, I'm going to reach out to Filippo or something, because that makes no sense to me. Then again, I've never done that before, so maybe when we see it, it will make sense, or it's a bad setting. I don't know. We talked about some artificial delay, putting that in.
Yep.
LLM to LLM conversations maybe turn. I think for sure it'd be nice to be able to turn it on and off at the UI level.
Yes.
I think that would be good. Yeah, LLM. Also, I was thinking, right now we've integrated that into the UI side of things, right? Which I think there was a part of my brain that was wondering if we didn't want to see if we could move it out of the UI side, only because, and man, this is only for Go stuff really, right?
Okay.
Well, because now if I want to add this to Datastar, I have to copy and paste a bunch of stuff as opposed to having it available there. Gotcha. And then I was thinking if you built a JavaScript, pure JavaScript client, and you ain't embedding, we don't want to embed that stuff in the JavaScript side, right?
No. And
then if you're going to do a pure JavaScript thing, would the whole thing be written in JavaScript, or would you want to extend a web API for some of the stuff, including this, right? That LLM calls and things like you would have to at that point.
Yeah.
So, we've cheated a little bit having the little Go client. But then again, one of the things that I've been really wanting to do with this project was to keep it decentralized, keep it where it only has a local footprint. And so the terminal UI has been like great for that, because once I start building a browser UI, why build that for something just local?
Yeah.
At that point now, I'm looking to sort of centralize you see, like I just tearing my brain apart with wanting to not do things in a sort of centralized way, right?
Yeah, that's the tricky part.
And really, at the end of the day, for what we're trying to accomplish here, I'm really trying to stay on the Go side more than anything else. So, I have these internal demons fighting me about should we have kept it on the UI side, even with the Datastar. But I don't think I'm going to develop anything more on the Datastar side. And moving this code over there really isn't a big deal, right? So sometimes the idea of not repeating yourself doesn't add any real value, though there's some boilerplate there. So there's just things going through my head. And then the whole Nats thing has been bothering me because I did some research yesterday on Tailscale.
Tailscale, okay.
So Tailscale is about you being able to build a mesh network. In other words, peer-to-peer communication with all peers on the network. So we were to sort of draw that out a little bit, thinking about, because this is what we have now, right? and I've got some diagrams here already. This is sort of what we have right now.
Yeah.
Right. And this is all great, except the fact that we're leveraging NATs in a very centralized way. Right.
Okay.
That's what we're doing.
Yeah.
It's if the Synadia wants to shut down this NAT system tomorrow.
Yeah, our system's down.
Kind of, right?
Mm-hmm.
We don't need the NATs, but it was nice because, and Tailscale calls this the sort of spoke and wheel, right? This is a spoke. We've created sort of a wheel around it.
Okay.
And it's simple. It gave us access where we're on local networks hiding behind, like we don't really have a public IP address here outside of what's happening with, let's say I'm using AT&T, right? So AT&T is basically giving me the ability to share an IP address with the rest of the world in a sense, okay?
Got it.
There's things called NAT. There's a whole bunch of stuff that goes on here. But I'm technically on a local network. I'm able to go out, but nobody's really able to come in.
Got it.
If you wanted to connect to my CAP, you can right now because you're on the same network as me.
Mm-hmm.
But if you were home, the only way that you could connect to my CAP is if I used ngrok. And ngrok is basically creating this same thing again, right?
Mm-hmm.
It's giving us a URL on the network where it will proxy traffic back and forth, right? So the only thing I like about maybe using ngrok would be this. So at the end of the day, a mesh network would be something like this, where let's say we had 3 caps, you, me, and Mohammed or something, right?
Yep.
Then what that would mean is you can connect to mine, I can connect to yours directly. We could do this today because we're on the same local network, okay? This would happen, and then this would happen. And for every machine that we add, it adds another level.
It just adds another, yeah.
But this is sort of like a mesh network, true peer-to-peer, completely decentralized.
Mm-hmm.
And this is what I want, really, at the end of the day.
Yeah.
But the problem, again, is we could do this if we're all on the same local network, but we're not on the same local network. And so even if I wanted to use ngrok, okay, what would happen is I'd have to run a little ngrok service here. We could do that. You could use brew to download ngrok. I have it here. And then there's essentially an ngrok service in the middle. And then what would happen is these lines would just sort of change from being here to being here. And then essentially that's connecting here.
Got it.
So,
okay.
Right? And so even if I wanted to switch to peer-to-peer right now, because we're sitting behind firewalls and local NAT, which is like network address translations and all this stuff, I would just be swapping one thing for the other. Because if ngrok decided that they weren't going to offer this service anymore, we wouldn't be able to do a peer-to-peer community. It'd be more peer-to-peer, though, in this environment, because you really would be having this cap talk to this cap through. Actually, I don't even think it would be more peer-to-peer. We're still going through an ngrok client. If anything, I'm adding one more sort of component. So at the end of the day, what I really want is this ability to just have caps talk to each other.
With nothing in between.
I started looking at Tailscale. And the idea of Tailscale is that you get this, right? But caps, and they have networking magic that breaks through NAT servers and all this stuff. I mean, it's the next level of networking, okay? So they've created technology based on the protocols that are used today to be able to, without firewall rules and opening up stuff, sort of get connections through these boxes, modems, NAT servers that we have sitting here. But my brain kept going, I mean, how are they really doing that? And what was funny is when I read their docs, they still had something in the middle but it wasn't for connectivity like you see with NATs. It was some sort of like registry that had information about everybody that would be on the mesh network, including the public key for these systems. So there could be encryption over this. So you'd have a secure connection, right? So at the end of the day, they call it whatever they want. They had a global database in a sense where and obviously you got to use their client, right? So they'd have a client here that would do all the magic. That's fine. I don't really have a problem with that. No different than the ngrok client in a sense. But this client again, TLDR high level, could query this database to get information about the other caps, say in our case caps on the network, and then help establish these peer-to-peer connections sort of across it.
Got it.
Okay. Another level of complexity. But if you're a company that needed VPNs and you don't want to be setting up VPNs, I mean, this solution's pretty badass.
Yeah.
Or you have desktops here and you're traveling in Europe and you want to access it and you don't want to go through the complexity of VPNs, right? Like this is badass stuff. Okay. And the work that they've done to be able to actually establish a peer-to-peer connection, because it is it's not ngrok, it's not NATs. At the end of the day, it is a pure peer-to-peer connection. But there was still this centralized sort of data that needed to be available in order to make that happen, right?
Got it.
So if we wanted to just go pure cap to cap, then you and I would have to open up ports on the firewall. We'd have to have a way for you on, let's say, your Verizon network, right? Because at the end of the day, I mean, you're on Verizon, T-Mobile, and I'm on, say, AT&T. Okay, I mean, if you look at the end of the day, if you go to your browser, if I go to my browser right here and I say, what is my IP address? Okay, that's my IP4. What does it say in your browser when you ask for what your IP address is? When I have my VPN on in Europe, I always double check that it thinks I'm in Miami, right?
Okay.
So do you notice that your IP address is the same as my IP address?
Yeah.
Okay, right? So here are two computers sharing the same IP address. It doesn't work on the real internet. You couldn't have that. This is like your address on the street. You can't have two people with the same address. And so what's happening is that with the networking equipment that is there in AT&T, right? They're basically letting thousands of computers share this IP address.
Got it.
Okay. And they do the translations of data coming in on this IP address. Oh, that's going to this home. Oh, it's going to that home. And then it even from there has to get down to this computer versus that computer. And all right.
Networking.
And Tailscale has learned how to like break through some of this stuff without having to go and touch the firewall and open up the things. And it's very, very cool stuff, right? Like, again, beyond my pay grade. So that's what I'm saying, right? Like if we were purely on the internet, if I had a static IP address and you had a static IP address, this would be easy. Just what's your IP address?
Boom. Yeah.
But that's just not the case. Now, on the local network, you have your own IP address. If I go over to here and I say, I think it's ifconfig, you'll get all of the interfaces that are on your machine here. And here's the local one, but again, I never remember which one to look at, but there'll be here, EN0. That is the broadcast. That is that. I should have had a IP address here other than, look for your EN0.
Yep, I have it here.
Okay, and it says 229, right, for you? And I'm what? 227.
Okay.
So you see on the local network, I have a 192 is an IP address reserved for local networks. That and I think 10.10 You see in a lot of businesses.
Yeah.
192 you'll see here. So you'll either see 192, 168, or like 10.10. Those are reserved for local networks. We won't see them on say the public network. So that machine over there, that networking machine, when something comes in, right, over the public IP address that we're sharing, and then it also has to translate that back to is it for 227? Is it for 220? I don't know how all that works, but I think it keeps track of what's going in and out, right? Like the box right there.
Gotcha. Okay.
So again, they've found a way to break through sort of all of that with their little client, and you're able to establish a true sort of peer-to-peer connection even behind all this networking. Cool stuff, right?
Yeah. Very cool.
All right. So, so my point is that as much as I want to get rid of NATs, replacing it with ngrok doesn't get rid of the spoke and wheel, doesn't really give us a mesh network, because all communication would still go through ngrok. If we were to bring in the complexity of Tailscale, and they have a free sort of option for like 5 machines, now it's another level of complexity for everybody to run the client, and like my brain just hurts wanting to do that. And so I kind of just come back and I say, you know what? We could spend all this time trying to rebuild Tailscale, which is what we'd have to do.
Yeah.
And it just doesn't make sense. And integrating it just doesn't make sense for where we're at with what we're doing. And so I just come back to NATS has provided this sort of public system out there that we can leverage. And it, as we've already learned, it's the simplest way to just create this connectivity, right?
Yeah.
Now, again, Delaney was complaining that why are you even using the cap at that point? Your client could connect. But again, I like the idea of the cap sort of consolidating some of the local routing, right? We could have a couple clients connected to the cap locally if we wanted, not even go out up on the NATS thing. We were doing the encryption and all that as well, sort of that. So though I think we were doing the encryption not at the cap level, we had to do it at the client level anyway, because that's where we have the public and private keys, right?
Yes.
And so I think it's an interesting discussion to say, can we get rid of the cap? But I don't, there's a part of my brain that says maybe you could, but I think then you're putting too much, say, into the client. And I like sort of consolidating some of this complexity that we did here.
Yeah.
There, right? And trying to keep the clients a little bit more focused on what they're doing, especially, like I said, if we wanted to go to a JavaScript client, which maybe we end up doing at some point. So I don't think we should ever remove NATs for the peer-to-peer networking stuff, right? I was really hoping that Tailscale would be a little simpler to do that, but I don't see it, man. Like, I don't see the need for doing this. However, I still want to do data transfer stuff. And so I think private streams potentially comes back and gets interesting. And so instead of just publishing everything on NATS and sort of overloading it, right? If we could create a private stream for 2 people, at least the data is more isolated and more. If it's more isolated, then it's sort of more secure. We don't have to necessarily worry about somebody else attaching to it. Because right now with NATS, the way we're doing it, every cap gets just every message that's going in, right? Whether it's encrypted or not.
Got it.
And so at least we'd isolate that down and we'd have to create. So I think this is definitely worth our time sort of talking about it. And then I think if we do that, the group chat gets more interesting because
everyone's on the same private
stream. It's a private stream for that group, and so only that group would receive. Yeah. And so but the moment we do this, see, here's the problem. The moment we do this, now we've become completely dependent on NATS. See, right now, all we've done with NATS is used it to publish a message, right? So we can pretend that we have a mesh network,
Got it.
To
Okay.
technically get rid of NATs right now and do something else to create the mesh, I could publish a service out there in the public internet that could do what actually simpler than what all NATs is about, because all we care about are caps connecting to it and then it all moving that data around, right?
Yeah.
Maybe that is going to be better for us with this project here, right? Maybe what we should do is, and again, it's going to be something centralized, right?
Yep.
But what if we built our own sort of mesh service, okay? And we'd have to publish that. So maybe we publish that using the Google Cloud Run.
Oh, that would be cool to see how
Right?
that works.
Yeah,
Also,
as long as we're not like, you have to be really careful with
Yeah,
keys and stuff. Okay.
yes,
There may be some stuff we have to do when we're not online, but we can share it without the keys.
exactly.
Because if we built our own mesh service, essentially all we need, like NATS is overkill for what we need right now.
Yeah.
We're using it. But what we could do, if I come back to sort of this, I'm going to get rid of this diagram here, right? What we could do, and I think it would be more interesting anyway, is to replace NATS, right, with our own mesh service. And you just real simple, right? It accepts a connection. And this could be, we could do this with HTTPS actually, right? Because we'll have that from Google, we'll get the cert. So it doesn't even have to be a straight up solid socket connection, right? We could do HTTPS. So a message comes in, push it to the mesh. Now, the question is, we could push it to the mesh, but then how the cap is sort of getting it. Would we be doing polling? Would we be doing, so maybe we can't do that. Maybe we need maybe this has to be done over TCP, where we maintain a solid connection. If it drops, we work on getting it connected. And that way it's two-way communication here. So when a message comes in, we can push it to the other caps.
Got it.
Right?
Okay.
And then we can rip NATs out. We don't need it. This has to be out on the public internet, the public IP address. Okay. We can use Cloud Run to deploy it. It's not going to cost us anything to do that. And at least, right, it's centralized in the sense that we run the mesh. That has to be up and running. But I think it's about as decentralized as we're ever going to get. And again, then somebody else could sort of deploy their mesh network, their mesh service if they wanted to as well. And eventually, right, you take this whole nother level. If you really wanted to, then you can even connect meshes together, right? Our little mesh, like, which we won't do, but
Gotcha. Okay.
like you see how this can go,
Yeah, it could
go crazy. But right now we're leveraging NATs. There's just no way around it. There's no way I see around this without adding a large amount of complexity, even if it was Tailscale. Now, I used to know some people at Tailscale. Maybe what I do is I reach out to them, show them the project that we're working on, and maybe I can get somebody to come on and say, Bill, it's not as complicated as you.
That would be cool too.
As you think. So maybe I'll reach out to some people over there and share that. But because if we can do an actual mesh without the complexity of having to deploy anything in the public internet, that's the key. But again, remember, when we do that, we're still relying on Tailscale to give us that infrastructure to make it all work.
Gotcha.
But they're not in the middle of any of the conversation. There's nothing that's seeing any conversation going on. The networking truly is private once things happen. That's the nice thing about Tailscale, right? Because our messages are still going to be doing this, right? But if with Tailscale, you would get this, and you'd get this, and you'd get this.
Got it. Okay.
Right?
It'd be more.
So now you want to do file transfer. It's here, it's here, it's here, where we're sort of still proxying connection. So I'm going to reach out to Tailscale, see if somebody will jump on, tell them what we're doing, see if somebody will jump on and help us. Maybe look at that as a solution. Worst case, if we want to get rid of NATs, we could build this. That ain't going to be that hard to build. But at least it gets us off somebody else's technology, and it's all sort of here, right?
No, it's all.
And we won't even, we won't worry about this at all. Somebody could do it. But everybody that's been following and watching online, then we just have the caps sort of connect. We can even hard code in there where the mesh is, man.
Oh,
right?
okay.
It ain't going to change. But you understand what I'm saying. So these are things I've been sort of thinking about. And if we do that, then we have to do that sort of in this order, right? So after a half an hour of talking, this is where my head is related to the project. And so what I'll do is I'll reach out to Tailscale, tell them what we're trying to do, and see if I can get somebody. I might know a couple people.
That would be cool.
That can maybe jump on just to see it.
Another technology and see how it works.
It would give us the peer-to-peer networking that would be really nice. Okay, right now, but even before we bring them on, I'm going to talk to them. If somebody over there agrees to come on, then what we're going to need to do and get this working first is cap-to-cap communication. So what we're going to need to do then is for us to sit here and get two caps, the one running on your machine and the one running on my machine, to talk to each other, like turn off NATs and have us send messages to each other through our cap. Because until I have that, I can't bring them in, because we're like, that's the connection that we have to mesh together, the cap-to-cap stuff, not the client.
Got it.
The client is connected to our cap, right?
Got it. Okay.
And so if they come in and agree that this is something that they could help us look at and explore with the audience, then we've got to do that first. If they don't agree, there's no reason to code. But what we would have to do with this would be pretty much the same as this. It would be a TCP protocol. We'll build our own, and we'll just send things out.
So even if we did do our own mesh service, we'd still have to do the cap-to-cap?
No, but the work we'd have to do for cap-to-cap would now just be from cap to mesh.
Got it.
Same thing. It's a TCP connection. We'll write our own little protocol to move the data by bytes. I'll show you lower level. Right. This is essentially going to be. This would be, we can do some socket level communication. I had to do all that stuff in the late 90s and early 2000s, and I have a Go package I wrote a million years ago that helped with that and discovering disconnects. And I got to go find it, but we could bring it in and do some socket level sort of communication. So if they decide that they can help us, we got to do this first. If it just doesn't make sense, then we can build the mesh service and then do essentially, right, we'll run it in Cloud Run, but also essentially that's going to be, we need socket level communication between the mesh and the cap.
Got it. Okay.
Right. And then we can rip out the NATs piece and sort of control that. Again, just own more of our destiny.
Yes.
NATs is doing much more than we need right now. We don't really need persistence and any of that sort of stuff. Okay, so somewhat of a roadmap as I think about this, but right now this is our big problem.
Yes, the encryption.
Yeah, this is like bumming me out, dude. That we had to.
Which the message wasn't even that much longer than anything else.
I didn't think it was that long.
It
so
seemed to be the same.
My problem now is I got to remember where all that stuff is. So I've got to look at this main here, right? And we got our cap ID, we got our chat bus. It might be in the chat bus. Let's see. That's at the business level, domain, chat bus. Let's see here. So we got to remember where all this happens. There is the handshake. There's a listen client. And here we did the signature to make sure everything is good. Listen bus. So, oh, remember, we don't do this at the cap level. Shoot.
We're doing it in the...
We do it at the client level.
Yes.
Yeah. So let's take a look at the client level again. So handshake, receive a cap message. It might be in the pre-processed receive message, but
Send that.
pre-processed send message. Let's take a look here. Decrypt and then encrypt. So we were using this right here. Encrypts the given message with the RSA and the padding scheme.
Oh,
message.
the must be no longer than the length of the public modulus minus 11 bytes.
Okay.
What is the public modulus?
Maybe it's that random value in there. Okay, the message must be no longer than the length of the public modulus. Okay. The random parameter is used as a source of entry message. Application should use this function uses. Okay, so we now know what the problem is, right? Like, even if I just came in here for a second and did this.
2048 to 56.
Due to the mechanism of RSA encryption.
Yeah.
So it's the key that we're using here. And get public key, given a key. Oh, so when we created the key, we probably used a 2048-bit key, right? I go back to Zarf, and I went to client, and I went to keys, right? We used I didn't know this. I think we used a 2048 key.
I want to say we did also.
Did I ever keep, I don't remember how we created the key, unless we used some, how did we, oh, we have code that creates the key, I'm guessing, right? Question is, how do we create the key?
Get part.
Yeah, we're gonna find, here it is. I think this is it. Create an encryption key.
Yeah.
Here it is. So
2048.
Okay, so we're using a 2048 bits, and this says with a 2048 bit 256 bytes. So
the maximum message length is 245.
Yeah. Now, that would mean that we would have to use a much bigger sort of key here for that. But what I'm wondering is how people actually sort of do this when the data is going to be as big as what our data is going to be, right?
Yeah.
Do we have to break this up into 256, like, or say 250 byte chunks, and then encrypt in chunks? Because, right, here they're using a 40 right?
96.
That gives you 512, but even 512 might not be 512 bytes. I mean, that's not even that's not a lot of words, right?
So this would almost be like we'd have to chunk up the responses in a way.
I think when encryption, I think what we'll have to do is chunk this up into like 250 byte chunks.
Yep.
Encrypt those 250 byte chunks at a time, and then we can sort of put that all together in the string with some form of a marker.
Okay.
Okay. With some form of a marker. So let's take a look at how we can do that. The problem is the marker has to really be sort of unique. And if that marker would ever find itself in the data itself, we would be in trouble. We'd be.
So you're saying, as a marker, you're saying like, this is the end of this chunk. This is the end of this chunk. This is the end. Okay.
Yeah, if we did that, then we have a complete sort of byte set.
Yeah.
Now, we could try to assume right now that when we encrypt data, there would never be a byte set to, say, 0. I don't know how true that is, but if that was the case, if we never had a byte 0, 0 could be our sort of marker for this. And I'm saying it in terms of trying not to break the current sort of structure we have. So if I go to the client for a second, right now this is a message. A message is content,
Yep.
right? It's just a slice of bytes. Now, and then there's a user as a slice of messages. So one thing we could do is this.
A slice of a slice of bytes.
A slice of a slice. Now that starts to break things a little bit, but then we wouldn't have to worry about markers. We would just take content, take 256 bytes, encrypt that, put it in there, put it in there, put it in there, and then just reassemble it on the other side, right? This would be the sort of the easiest way to solve this problem. Now, this has ramifications everywhere.
Yeah.
Because even on the business side, this is the incoming message, right? Now, on the cap side, it's not really a big deal because we don't do anything with a message. We're just sort of proxying it, right?
We're passing it through.
Proxying it through. So if we start on the cap side for a second, and we do that, and we say this is a slice of a multi-slice here, right? Solves that problem. And then this. So on the cap side, it doesn't hurt us because we're not doing anything with the data, right? Now I just said that everything is a slice of bytes.
Yeah.
Okay. Whether it's encrypted or not. If it's not encrypted, we could just go with a single slice. If it's encrypted, we can do multi, right? Now, this is breaking this a little bit because now what this suggests is we have a slice of a slice, and you can't just convert that to a string. So if you see here now, we're going to have to fix this where this is why I hate this stuff. So here's your string that he took, right? And then he returned it with the errors. But now what we have, if I go back to this is a slice of a slice, right? So to fix this compiler error, I don't know if we end up breaking anything. It's going to have to be that. And then to get the string, and I'm just going to sort of like really hack this right now. Let me just write it this way first, and then I'll look at it. Ideally, what we want to do is for I, let's just call it v range over messages. And this is really bad what I'm about to do. Well, let's just do it a little bit better then. Strings.builder. Okay. And then s dot write string, or is it just a write byte? We can do that, which would be at that point just v. I don't need I here. All right. So we're writing. See, and then this is s dot string, which is essentially what we're going to end up doing, right? We're going to take this and reassemble those bytes into a single byte stream,
Got it. Okay.
Then I can convert that into a string. So that solves. Oh,
Yeah, this is.
that's some of his code right there.
No, this isn't a vendor.
No, I can't do this. But we have to move that up. So let me undo that. I thought that was some of his code.
No.
Like
this is the generated file.
This is the generated
Yeah,
file.
so we have to go
in here.
there. Yeah.
Oh, all right. Join strings error. So question is, where is that being used? Join strings error. Join. Dude.
Message.
Chat message fragment.
Yeah.
Chat fragment.
Chat fragment. Chat message fragment. Messages of length of messages is 0.
I know, but you see what he did? He
string message.
So that's the problem here, right?
Yeah.
So again, I have all that off because I can't get rid of linter issues. But if I do that, then this essentially is s.string. All right, and that would solve that problem. I should be able to, what do I do again? For data star is, I don't want to run it, I just want to do the template.
Run data star reload.
This.
Oh,
Yeah.
that.
So that should get rid of our other issues there. Still have that.
Now more.
Slice a client message. Yeah, dude, what a nightmare now. You see, like part of me not wanting to sort of change this, but messages. Oh, shit, this is a nightmare because he sent in a slice of messages. And so messages here is not, damn it. Okay. So this had a slice of messages already. I'm going to undo what I did here for a minute. Go back to the fact that it doesn't like this because this is a slice of a slice, message content, right?
Mm-hmm.
And now we're in here. So, oh, message content. I wish I hadn't lost that code now. I think what we have to do is this again. This is my bad. Message content.
Oh, okay.
It was message content, right?
Okay, I see. String
builder. And then come in here and just say s dot write v. And then here I can do s dot string. I think that solves the problem. We should have been using
the message
content. Okay. And that should fix everything there. So it doesn't know what S is now. Doesn't know what V is now. Declared and not used. Let's go double check our code here. Because I don't have the syntax stuff in here.
No.
But this feels... Oh, man.
That. Yep.
This, right?
Yep.
All right, let's enable it. V is declared and not used, except I'm using it here. For bot dash range. Really weird. And s dot, see, I don't want write string. V, right? V is a slice of bytes. So this is really weird, right? Because it should let me do this unless I can't do this in here because it's a Templ thing. Then again, here's a div, and then there's some Go code, right? Okay, so essentially, let's just double check this for 1 second. I just need some Go code to throw this into real quick. Right. All right. So this is correct, right? Okay. May have to just turn all this stuff off because I don't see a syntax error here. I don't see it. Declared V. What am I doing wrong here? For bot doesn't equal range. I mean equals range message, right? And then even though S is declared up there, it says it's undefined. So
it's all in the for the outer one.
Yeah, I don't know, bro. This I don't know. So, and I just don't want to be stuck here, you know. That's the worst part about it. I don't want to be stuck here when I feel pretty confident that that code is right. And I just hit save and I don't know. Maybe it was just slow? No. All right. Yeah,
I'm not sure on that one.
I don't either. It knows it's a double slice. It knows it's this. This S, it's confused. So, but we know this is right, right?
Yeah.
We know that is right.
Now the error message is gone, which is...
Yeah. What's
weird, it doesn't know what like that is.
Yeah, it doesn't know what this is for sure. It's almost like it's out of scope for some reason. But it has to be inside this loop. There's just no way around that if we're doing this right. And I don't see the S variable being used for anything else. So, like, I know there's no variable named Bill. Right. So, I don't know, dude. This is super confusing for me that it's just not working. So, we got to make a decision here to just abandon this for now. See, that's the code. I'm going to generate it. Just generated it. But it doesn't know what Bill is anymore.
So V. 4V. Yep.
Right? Because here's... Oh, that still says V, which is fine, I guess. Oh, but it didn't use it. If you notice, it didn't get injected in the code. Oh. So it didn't get injected in the code. Okay. So that's the problem, right? When you look at the code generation, he did this.
And then Bill.
But he didn't... This extra loop doesn't get... But we need that to happen before we get to the div is the problem. And I need this to produce a div with the messages. And so this to me is like some sort of weird bug.
Messages var Bill.
This is becoming part of the HTML. Oh.
Div.
Oh. This is becoming part of the HTML, dude. You see that?
Yeah.
It's not being treated as
Go
code. Oh. Ooh. Maybe he doesn't recognize the syntax here. I mean, I don't know, but even that's weird. I mean, this would be the other way to do it, but he's generating it. See what he's doing? He's turning it into like HTML and not.
Yeah, it's not recognizing it as.
I mean, at that point, I don't know
Yeah.
what you're supposed to do, other than I already proved that this is proper syntax. Right? I mean, this is right. So, I don't know, dude.
Interesting.
Yeah, to me, super interesting. All right. So, I just don't want to deal with this right now at any level. So, what I'm going to do, even though this is now going to be broken, now it's going to be broken, but isn't message a slice? Oh,
I think it was just.
dot
Yeah.
content, sorry. Okay. So, gets us out of that hole, even though it's wrong.
Nope.
But how terrible is that I could only put this loop and I couldn't have another loop inside of it, sort of where I needed it, right?
Yeah, that was
Because
interesting.
I essentially needed a loop here.
But that's because it's inside of.
Oh, it should
Oh, no.
It should have been fine, right? Yes.
I was thinking because it's inside of those divs, or that div, declaring the variable in there.
I don't know. Let's see what happens if I move it here. Move it down.
That's
We
not
got
right.
closer. It
Div.
now generated a loop, but it got closer, right? It now generated that loop, but it didn't declare S. See? Didn't declare S. So there's something really weird about.
Could we move that S up here and still have scope?
I mean, I could, but now I got to do an S dot reset. Maybe I don't know what the API is for that.
Okay.
I don't know if there is an API for that. Let's see. Oh yeah, S dot reset. All right. I mean, that would be the only option. Is I put it there. We do a reset. But you can see here.
It's still taking the S dot reset as HTML.
Yeah, it's not declaring it, and it's just I have a loop now, but the problem is that it wrote S dot right in here
rather than
instead of there being some HTML. You see how we did pretty print inside of this?
Mm-hmm. Inside of the brackets. Now I recognized it.
Could it be that to call functions we have to do this?
Yeah, now it's reading it as Go code. So maybe it'll work before how you had it with the string builder. Lower.
Well, even
Or
this
just
is fun.
doing the brackets. Why is S?
Because I think we didn't put that in brackets, so it doesn't know. Like even that's in brackets, right?
Yeah, but why is it still red?
Yeah, I don't know.
The var.
Now it doesn't know what that is. And maybe it doesn't understand var. But now the problem is I have to do this. So maybe he didn't understand var, right? And line 103. So,
comma.
What do you mean missing comma?
It said missing comma in this. Or an argument list.
I don't know, dude. But it's interesting to me that I wonder if you can even just do this. Stop trying to help me, man. Like, you know, like just put
like
it
the
all,
whole thing into
yeah, but it doesn't like that either, right? Now everything is messed up. So what a bummer here.
Yeah, the only way it recognizes it is in brackets.
So now you're close because, but it doesn't know what S is the problem. Actually, I don't even see the, yeah. That's the new loop, right?
Yeah, it's up here.
But it doesn't know what S is. So this is horrible, right? It doesn't, I can't get it to, I had some, it looks like the curly brackets became important to make function calls and things like that. But I guess it just doesn't support this type of scenario. Again, I just don't want to spend time on this, dude. So we're just going to do what I did before. And
message content, right?
Yeah, message that content. And just leave this for another day, even though it won't be perfect. It is what it is. Okay, let's go back to sort of where we were. So on the, I don't care about you right now. In fact, I feel like that was bad anyway, because was this using? I don't even know where it got the type from, really, because it shouldn't have been using a business level type. Oh, changed the client. That's why. Okay. Okay. So we came in. Oh, right now, all we've changed is cap stuff. So there's a message at the client level. We get a slice of those. That's an outgoing message. This is a double, isn't it? That's an incoming message. That's a double. Everything else there is fine. Let's see. Now, no, it's okay. We received a message from the cap, right?
Yep.
Okay. We pre-process the received message, which is supposed to give us back a single message.
A single slice of bytes.
Right.
Okay.
Now, in here, we checked to see if the first byte was a slash. Technically, we could use this if we did that right. It's the same thing, I think. We're going to fix this. And then this message, I have to change this. Okay, let's start here. We got the incoming message. Are we processing? If the first byte, so technically if the
Yeah, it would be zeros.
first byte of the first message,
Mm-hmm.
and then we got to return this back.
No, everybody moves to double.
Yeah. Decrypted data. Right. Then we return some new one. So we essentially need, there's going to be a more efficient way to do this, but that's what that's going to have to be. We're then going to have to say for the message, for each message,
got it. Okay, I see.
And really, we could make this plural. So messages, 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 a message.
A message.
Okay.
Yep. Okay.
Well, the cap's going to assume that everything was already, this is going to assume that it's already under 250 bytes. So, because we're de-encrypting it. So this is the decrypted data. And if that works, now we can be smart about this because I can say make a slice of that with a length of messages.
Okay.
And now I can use I, and then I can say the decrypted data sub I equals the decrypted data. Now we're decrypting each sort of slice as it goes and then putting it back out, right?
Mm-hmm.
So that's our process. This is client level stuff. So that's our process received message. So we've got that. Now, if in our case here, we'd only have a message in the first position. Okay.
Because that would be the command.
That would be the command.
Yep.
And to return that, we would need to do this, but can't do it that way. I would need to do it. I've never tried a double slice where I'm just doing the construction right there. That's super interesting. Because this is a conversion of a string to a slice of bytes, and then I have to put that in a slice. So that's a super interesting, super interesting, actually. I don't even, right now I'm hacking. I mean, if I did this just for a second. Huh. How would you do this? I need, trying to think how you would do this. I need to create a slice of bytes, and then I want to put that in the first byte position. I wonder if this will work in here. Huh, yeah, that's it.
Interesting.
I will put the first slice in there for sure. I don't know if this is probably not redundant because I've got to do the conversion. So what this just did is loop through all the messages if it's encrypted and decrypted them all,
Yep.
one after the other. Now, we're going to do the same thing here. If that's not 0, on wire, on screen, error. You see why I just wanted to keep everything in one string?
Yeah.
Right? With some form of a marker. But I can't assume that. I can use byte 0, not the number 0, but like null, right?
Okay.
Nil, 0 as a marker, because that could be part of the data. So encrypted stuff, like it's complicated. So if I do that, now the encryption, we get back to
doing that same sort of thing.
This idea. So this would be the encrypted data now.
Yeah.
Okay. I'm going to call this messages. And ED or that.
Yep.
And we need the same loop, right? Just steal it. And if it doesn't fail, then encrypted data sub I equals that.
Okay. Messages.
So now we've encrypted each sort of small section. Wherever we call that is where we're going to have to break it up.
Yes.
And then to process the commands, we just look at index 0. All that should be the same. And then we're back to the little hacky sack that I did here, right? Let me see. Something wrong here though. All right, because this is a string, so it's already a slice of bytes.
We don't have to do the conversion.
Just do that. Do that. But I'm missing something. Hold on. Oh. This is the editor trying to be nice to me. Okay. So now a slice of that slice with that one in thing in there. So that solves those problems, right?
So this is putting error message in the first position of
a construction of a slice. And since slices work in their 0 value state, that should be fine.
Okay.
So we're now able to pre-process messages in one form or another.
We do have an error there with this.
Yeah. We received a cat message here. We want to know if this is a command. What we haven't done yet, though,
pre-process,
is the breaking up the message. We haven't done that yet.
Yeah.
And that's going to be coming in here. You see,
in send message handler, it's going to be sending a slice of
the slices here. So this is where the rubber hits the road, right? You want to send this message. So we're going to have this slice of bytes. Now, we don't want more than, let's say, 250 bytes for this. Now, the problem is, if I range over this, okay, I can range over these bytes, right?
Yeah.
So let's just go really like bad for a second. I can range over the bytes, okay? And then I could be really, really inefficient. I mean, let's just look at this at its most inefficient level here,
Yeah.
okay? This is not how I want to end.
Oh.
I could just count, and every time I get to 250, append that, right? I mean, super inefficient, right?
Yeah. You're just counting bytes.
But I can do this. I can say if count equals 250, then essentially messages equals messages. Cut that out. Restart the count and do it again. This would essentially, now it's a linear traversal, it would be super fast. And I could do that. I could try to be clever right now and try to say divide that by 250, and then that's how many iterations of this that we have to do. But right now, I'm gonna leave a to do, because this isn't the biggest problem that I have right now.
Yeah.
Okay, and we can come back once we know everything's working and make this more efficient.
Okay.
Instead of sitting here trying to like be smarter about this, when at the end of the day I know this will work. Now there is one mistake here, I think. Count is 250, so we went from 0 to I. Then the new, I don't know if this will work, dude. Because once I slice this, no, this isn't the right way to do it. I want to keep it this simple, though. I do want to go from, okay, on the first one, I need to go from 0 essentially to count, which I happens to be.
Which I happens to be.
But count is going to grow now. So I'd like to go from essentially, instead of slicing that off, I just need to get the next sort of count. Oh man. So say I need to go from 0 to 250 and then 250 to, since I'm in a loop, even though it's pointer semantic loop, I can't just slice that and then I don't think I start over there. All right, we're gonna have to do something here. I don't think this is right at all. We're gonna have to go to the playground, even though we can be more efficient here. I'm gonna go to the playground. So we're gonna create a message right now. We'll use the number like 3, right?
Okay.
So let's just do this. Var message. It's a rainy day in Miami. Okay. And we're going to slice, we're going to range over the bytes. So
got it.
Ideally, let's say every 3, right? I don't remember the behavior of doing this in a range that's basically using pointer semantics.
Value of type string as byte value.
Okay, this is what I have to do here.
Yeah.
And that's what I thought. Yeah, it's not gonna take that. It's just that's not gonna work. So see, there's Copilot giving you code. It's completely wrong.
Yeah, that's
And
bad.
my brain realized it pretty quickly. So again, I don't care about efficiency here, right? And then this I has to be so this will work for the first one, but I have to use count.
Yeah.
So it's almost like maybe, I don't know. Okay, that's no big deal. Let's just do this. For V, it took way too long. But again, I'm not looking for efficiency right now, right?
Yeah.
Okay. Do fumped without a print line. V. I'll do a fump.print. Okay, I lost my cursor.
Yep.
Whatever. Okay. So did it not run? V. Oh. String. Sorry. Okay. So
Maya, and then I cut it off.
yeah, it's not perfect. In fact, we've got the it's sort of twice here.
Mm-hmm.
All right.
Interesting.
And Miami. So we said stop at 3, 1, 2, 3. And at that point, we said start from 0 to 3, not including 3. That would have been 0, 1, 2. That was good. We set count to 0, and we set start now to be I, which was, I'm not even using I here. Maybe, I don't know. All right. And we set it to 3, all right? Probably should have set it to 2, though, because it's a starting index is the problem. All right. So that was definitely not right. I'm trying to do it in my head, and I just can't. So we go back to 0. Start is now 3. 0, 1, 2. 0, 1, 2. Oh, yeah, no, 3 is probably right. And then on the next one, when count gets to 3, we said 3 plus 3 is 6, not including 6. So that would have been 3, 4. No, I don't know why it didn't work. Oh, but we get to the end of the loop is the problem.
Mm-hmm.
So if count equals 3 or length message, come on, Bill, -1 equals I, something like that. Okay.
It's already.
Yeah, so now I'm saying if count equals 3 or I equals the length, still miss the I there. So there's something there.
Yeah, why is it not?
Yeah, because I will never be the length. Once it's the length, once I equals length -1, we've hit the last byte there. So there's 2 crazy things going on here, right? We're getting, my guess is we're starting in the wrong place here. So let's do this first of all, just so we can see. So we did good on the first one, right? And I'll even do this just to help us. sometimes there's a gap there and you don't see it until you
Yeah.
put a bracket on it.
Okay.
So the
1, 2,
first one
3.
is good, but the second one
It's
should have
starting.
started at an S, and it started at, so like if I do that,
It needs to be offset.
okay, and I run this. No, that's good. It's rainy day in Miami.
Yeah.
Now if I get rid of this, that was the problem, right? Okay. So this little code here is giving us back, it's giving us in every 3, right?
Mm-hmm.
While we iterate over that and just count, like fairly slow sort of algorithm. The other option here is you could do something like equals the length of message. Say 3 is our number.
That's what
right?
I was thinking, like a modulus.
So if we did that, print line, what do we end up with? We end up with, well, that's wrong.
Length of message, or is it messages?
No, it's this.
Oh no, message.
Now, it is bytes, so so there's 25 bytes there. I don't know why 25 bytes mod 3 is 1.
Yeah, that's interesting.
25 bytes mod 3 should have been at least 7, 8. Should have been 8, right?
8, but there's a remainder.
No, it's not a mod, dude. It's just a regular divide. Idiot. Sorry, that's my fault.
Yeah, it gives us a remainder.
Okay. Yeah. So there's 8 iterations really to pull that from, right? So now you could say for, I don't know, range. I wonder if I can do V here. Okay. So now we've got 8 iterations, right? And I can just say front.println message sub what? On the very first one, I is 0. And then that would be just say I plus 3. On the second one, I would be 2, but we really don't want to start on I, 2. We want to start on...
Well, we want to start on 3.
We want to start on the number that we ended here, right?
Yeah.
Honestly. So if I say just for now, start again. I can hard code 3 as this number. Then start is going to equal.
So that's almost going to be end.
Start plus 3. Yeah. Oh, he's starting it. Start 2. As I hack here. And we're not using I. Oh, I got so much code problems here. Oh, I don't need this. I'm not assigning anything. And
1, 2, 3, 1, 2, 3. It's a ring. Yeah, space.
We lost the last.
I am. Yeah.
we're losing the last. So
It needs to be offset again. Or one more.
yeah, so I get rid of this and I run it. So that's pretty interesting, right? Because that little piece of code is going to be much more efficient than the other one.
It's a lot less code.
However, we're missing the last
Maybe
byte. Everything else is perfect, though. It's a rainy day in Miami. And this is probably because
of the remainder.
of the remainder.
Like if you were to
It's
add
not evenly divisible by
3.
that number, right? And so, Mohammed is saying start equals. Yeah, well, we've moved on there, but okay. So here's our problem, right? We've got one more, right, to do. But now we're gonna panic because we're gonna be over the slice. Now we're gonna panic. See, because we're now over the bounds of the slice here.
So it's almost like we need to do a check if it's even or odd length.
Well, we got to make sure this math doesn't go over the length at the end of the day, right? So you're going to do this math, and if B is greater than the length of message, then B has to equal the length of message, so we don't go over. Still blew it up, but we got everything but that last I again, right? So that means to me, start 2 plus length. If B is greater than length, then, oh, I didn't use B. The whole point is to use B here. Okay, so that was the little problem, right? We had to just check our length there. But what's sort of nice about this code, I bring it back in here now. And this is going to be 250, right? So if I do that, I don't need this print. Say start here.
Start.
Then this is the sort of iterations, right? I don't know. Then this is the end. And now instead of this print, I'm going to go back to this for here.
You do the
and instead of the print, we're going to append this, right? Okay.
Got it.
So
okay.
that is giving us sort of what we need here. Okay. So now we're able to, where's the nonce used? Said I did it all the way up here. Let's move nonce here for a second. Is nonce used more than once? Yeah, it's used there. All right. So now what this code is doing is it's breaking up the message into the 250s, so we can do that, right?
Got it. Okay.
And even that, there still might still be a better, maybe a tiny bit more efficient way to do that, right? But this isn't too bad anymore. We're only going to range over this that many times, and even this I could clean up, and we can do this.
And then that needs to be max bytes.
Oh yeah, oh, we're in trouble. Good call. Good catch. Good catch. So not bad. Like, I mean, and it's efficient here. We're just getting the slices that are pointing to that. Hard to read though.
Yeah, a little. Unless you know
Hard
the
to read,
context.
right? And again, there still might even be a better way to sort of do that. But you see how I got to this code? I took the really inefficient way and said, okay, if I were just gonna do a linear traversal and walk one byte at a time,
And just play with it.
And now I know I've got a working algorithm, so now I can relax. Like, I got it working, but can we get it working better? And then we said, okay, let's attempt.
Get it working first, and then go back and polish
and
it.
then can we make it better? And then I'm sure Mohammed's going to turn around and go, well, Bill, here's a little less code.
Mm-hmm.
Sometimes less code makes it easier to read. Sometimes less code can make it worse.
Yeah.
Right.
Yeah.
So this to me is code that you almost need to document at some level, right? We're going to look at this later on, and we're not going to know what's going on, right?
Exactly.
So even at least that message is going to be better, right? We're going to split chunks into 256 bytes. And then, right, this code here is calculate the number of chunks, because that's what that is.
Yep.
Right? So that already tells me this variable should be called what?
Chunks.
Right?
Chunks misspelled. And the day also. The day.
So, I mean, that's our number of chunks. And then this, I think, is kind of obvious now, right? Last chunk might be smaller. And then we append that chunk. And so even just that little bit of comments there.
That'll help at least when we look at this in a few days.
Yeah. So that's good. So now what we've done is at the client level, have broken everything into 250 byte chunks, and we've encrypted that when it needs to be encrypted. This is send message channel. So we've broken it up here, and then we sign it at that level, right? It's going to be on wire. Then it will come back to us on the receive side. We can decrypt all of that. We're going to have to fix the UI to stitch it all back together, but we'll deal with that, right?
Got it. Okay.
And we're going to do it first without any encryption, obviously.
Mm-hmm.
So now this is what gets interesting, right? Error message, content, append F. So now we do this again, right?
Slice of bytes. Okay.
So we did that. Now storage gets interesting because
message.
Right. So what are we doing here? Query ID by contact. We're going to have to delete everything that we've got already written on disk and fix that. But so our message content from disk. So this is why I didn't want to do this, right?
Okay.
Because now all this has to be slices.
Slice of slice.
Yeah. But when we marshal that, it will be fine, right? We'll just read it in that way. Read messages from disk.
Returns
Yeah.
slice of message.
So all that's going to be fine. And now on the UI side.
Yeah.
Okay, so this is where we've got to stitch it all together here, right? That's where we've got to stitch it together. Now, you can see here that so I think what we should do is add a function that stitches the messages together.
So that way there's still just one message in the UI's perspective.
Yeah, because that's what it needs, right?
Yeah.
Even though everything here in the raw will be. So what if we added some stitch messages, right? Because that's what we need.
Which takes messages of slice of bytes and returns a slice of bytes.
Now, I wonder if the bytes package, see the bytes package has a buffer. See?
Okay.
So that's your stitch, right? Stitch
Yep.
messages, which would mean now everywhere that we had a red line, we could do, and it wants it in a string, right? So why don't we do that too?
Instead, give it a string. Okay. Perfect.
Right? Oh, I gotta make this capital. So stitch messages, right? I'll move it here. So, I don't know if I want to put in client or formats.
I feel like it's more of a formats.
Yeah. I guess we never needed that. I like to put the exported stuff first. So now this is all in client, right?
Yep.
So now here we can say client.stitch messages.
Message content. Uh-huh. And there's
Now let's see here. Content has to be a slice of a slice. Oh, this is supposed
This
to
is
take
the
a
one.
slice. Okay, so this is different because, let's get rid of this. This is different. In this case, we want to do our regular slice.
The slice of bytes one.
Bytes. Put that in there. Okay, so this is a major breaking change, right?
Yep.
But if we coded everything right, now it should work. So before I push it up, you're going to have to, under DB messages, this is all going to have to go away. I'm going to get rid of all these message files. And then we're going to have to share our keys again. But let's see if this just works first the other way. So I'm going to push this code change up.
Okay. So it was just what was inside messages.
Yeah, because the format just changed, right?
Got it. Okay.
Changing sort of the protocol really, because now we're doing multiple messages.
Yep.
Okay, so push that up. I mean, I pushed it up. Pull it down. Okay, there's a bunch of things we got to do now. I'm not going to run in AI mode. I don't know if that will cause it to not start, but I'm going to do a make, what is it, run cap?
Yep.
Okay. Make run cap. Now, I don't care about running Olama right now. or anything else. So I should be able to just say down here, make run TUI. Okay, good. I should be able to put Kevin there. So you're running your client, right?
Yep.
Okay, let me send a message first. Hi, Kevin. This is a test of an unencrypted message.
I got it.
Okay, so send it back to me. Send me a message. Okay, so by some miracle, that didn't break. And now you see we've got slices of messages here.
Got it. Okay.
Now, do we remember how to send our keys?
Slash, I thought it was slash,
Let's look.
slash share key.
Let's see. Foundation, client. Before you try that, hold on.
The command.
I think it's, yeah, key slash. Is it just slash?
I thought it was
Just slash key. Let me try just slash key. Okay, so it wasn't, or is it slash? Damn it.
slash share key.
Slash share key?
Yeah.
Where do you see the, oh, share space key.
Yeah. Slash share.
Oh, share space key.
It did something. Like I see it here.
Okay, let me look on my file now. Zarf client DB data JSON. Okay, so I have your key.
And
Where was that in the code? Oh, there it is. Share key. Okay, so now I have your key. You have my key, right?
Yep.
Okay, let's just try again. I'm going to say, hey, Kevin, trying encryption. You got it. Hey, Kevin, I'm trying encryption. You send it back. Okay, now you keep yours running.
Yep.
Now, I'm going to start the Olama here. Don't do that. You're just going to type to me.
Mm-hmm.
Dude, I can't believe that worked. Man, I get so lucky all the time. I'm going to do the Olama up. Oh, I looked again between our show to see if I could run Olama in Docker again with that GPU.
Uh-huh.
They just don't have support for the Mac.
Oh,
It
okay.
sucks. Okay, so I'm running that there. And this time I'm going to run in AI mode.
Yep.
Okay, so this time you send a message and we'll let agent mode respond. So that's the first time it's hitting it. I should probably on startup. Oh yeah. On startup, we should warm that up. Like we shouldn't wait for the first message. Okay, so that sucks that happened, right? Because that's everything that we just did was to try to fix this.
Yeah.
So that's okay. It's okay. I'm going to kill this.
But why would it still be an issue there?
Because we got a bug. I told you everything just don't work out of the box, bro.
Well, yeah, but
All right. Okay, we're going to find out right now. So the pre-processed send message was supposed to do this code here, right? And our messages were supposed to be in 256. I mean 250.
Oh,
right?
It's 245 was the number.
245 was the number.
I think, according to the...
Yeah, the spec, right?
I think it was 245.
So let's just bring it down to 240.
Yep.
All right, this is the only place that has to happen.
Yep.
Now, if you notice this, it thinks using a min modernizer. Let's see what that is. Oh. Dude, I don't even know what that is. What that does.
Minimum. Smallest value of a fixed number.
Oh, that's like some new stuff, dude. It's kind of cool that the linter or somebody knew about it.
Interesting.
Yeah. I don't know if I like it because who knows what that is. It's not necessarily a readability. So it gives you the min of the two numbers.
Got it.
Interesting. Okay. Yeah, nice. I like when I see the ... sometimes because now I'm learning something. All right, we're going to knock that back down to 240, right?
Yep.
Okay, so let me see what I did to my... Nothing here should have happened, though. Oh, somebody else sent me a message. Oh, I don't know who that is.
Oh, Mohammed.
Oh, Mohammed. Oh, Mohammed, hold on, though. Yeah, we finally got min-max. All right, let's try... let me run it again now. Okay, do that. Okay, Kevin's sending.
There it is.
Good work, buddy. Man, I used 250. I needed to use 240.
That's cool.
So you got that back. So I don't know how all that worked.
And it broke it up into the 3 sections. If you read it, like it. Oh, it responded to Mohammed.
I know, but
in the same window.
Yeah, same window. So we've got that bug there. Oh, that's a buggy bug.
So because I'm selected.
I know, but we've never had this situation where I've responded. That's why I've never had the situation where we've responded, because that was an automatic response.
Yeah.
Okay, so we got to fix that. Okay, we got to fix that bug. So now that we've got AI working, and we've got our encryption working now.
So it should almost like whenever the new message comes in AI mode, it should switch to that make that the current user.
It shouldn't write it to the screen unless that user is the current user.
Or that, yeah.
Right? Let's just see if we can find that code real quick. Actually, well, I'll push this in a second. So what happened now was we did an AI response, right?
Mm-hmm.
Send message handler. So it must be this code.
But I think that's in the UI code.
This is UI code. It's client. Oh, you think it's...
I think it's, like the TUI. The current user, current item.
This is the right text, right? So this is where we do the star. Yeah, but remember, the problem is that we hit submit. So come back here for a second. Remember that the UI agent response, right? That was, we put that in the text area, and then we hit the button handler
to auto submit it. But we're not telling it that if it's from a different user to switch to
No, I know. So the question is, so we had to put in the text area.
Yep.
And then we did the button handler.
Yep.
See? And the button handler here said, who is it to? History add.
Okay. Current item. And then it calls.
This is where we wrote it.
Yeah.
We didn't want to write it there. We didn't want to write it at that point. Because if I want to look at one thing before we make a change there. Oh, it's never encrypted in there, but. I didn't see the U in here, did I? So there's a couple interesting things going on there.
Yeah, the AI like response doesn't have a U.
But it may have, well, all right, let's just stick here for a second. The question is, when did we write it to the text area? I'm guessing this was it right here. Oh no, get text out of the, if it's empty.
When we're writing
we
it to
come
the
here.
screen, I think is here.
No, this is for an error though. This is an error.
Oh.
It didn't, the error, it failed, right?
Okay. Yeah. Oh.
So here we add it to history. And then we reset the text area. And adding it to the history shouldn't do anything on the UI side. We just maintain it. So let me come back and look at something here. Just to test. Okay, so it's okay. So forget about this for a second. Where is that happening?
Input capture, call the button handler.
It's got to happen in the button handler.
Yeah.
This takes it out of the text area. This clears it out of the text area. This only happens. Dude, where's the code that does that? Hold on. I hit enter, what I just did, right? Goes into the button handler. We set the text area. Okay, let's double check what we have here in terms of what is considered the text area. Enter message here, fine. And then the button text area text view. Text view. So write text adds everything to the text view. But this only writes it to the text view if there was an error. See what I'm saying?
Yeah.
So I don't know. This is crazy, bro.
Message content.
It must be in an event here. No, but it's not there, right? Maybe it's happening on the way back out.
Could it be here on 181?
What's on 181?
Like this?
I know, but that means that this got called. So at some point, this write text gets called, right? And my guess is it's getting called. We must have been doing it twice, and so it must be getting called, right? But my guess would be here then, if it was this, if it was getting called this way, it wouldn't have written it. We would have just gotten that. So I don't know, dude. This one's really hard.
Write text client message.
I don't know. This one's hard. Maybe it's happening in the send message handler. Hold on.
It could be. It's calling write text.
There it is.
Yeah. It's calling it.
It's right here. So it happens here. It happens here. Okay. So in the, I don't know if it's good or bad that we did it there, but in the send message handler, after we process it, oh, that gives us an indication that it went out.
Mm-hmm.
So, okay, so The fix has to be in here, which we won't know. So the fix does have to be in here. And so what happened was it came in here, right?
Yeah.
When do we write U? When do we add U? Like, how does
client.go 332.
We wrote text. So look at this, right? It's not a command. We added U to the name. We inserted the message, and then we write this same message out with my account.
As the ID and then U as the name.
So my account U, but the problem here is I don't know. This message here doesn't tell me who it's going to, because I have it here. I need the to information.
When you're writing text, now we need the to information.
Remember, this is down on the client. I don't know what was the selected thing, right? This message just had ID.
Because the UI knows who's selected.
But I need a to in here in order to pull this off, right? So let me see everywhere this is used. I don't care about that. So insert message. Okay. Receive a message, right? We received it. But here's a case, dude, where we received it and we're writing it. There is no concept of to. This is more like
what is...
Because look, that insert message is here. This is the one that we're dealing with, right?
Yeah.
To isn't matching this. So let's say I leave this blank for a minute.
This is from the one you're receiving, it looks like.
Yeah, this was receiving.
Okay.
And it was from, and we checked if the ID matched, right? And then here, sorry, and then here, which is the one in question, it's my ID, but I don't know the to. And I kind of want the to there.
Insert message is saying who it's going to.
Right. And I know you're bugging out because I pretended this doesn't exist, so just give me a second. So here's a case where the to isn't going to be empty. There's going to be a to information in there. All right?
Okay.
Because there's one case here. Where are we going? Here. This is a case where we're sending the message. Received. Oh, no. We received it.
This is the one where we receive.
Right. We received it.
And then send message handler.
Okay. And so the to actually in this case is that.
Yes.
That's our account, right? So ID from to. And then in this case, so I wonder why we called it ID and not from, right? In other words, why not call this from? I want to see what breaks. So that's from, isn't it? And it's from. And then in here, this is going to be from. Not to break anything there. And what a surprise. No,
All of that.
But again, I don't care too much here. And we'll fix the, that should be it, right? Let's do this for a second.
There, yep.
So that takes care of all that. And then here,
Message dot.
it was from. Okay, right? So this seems better to me for some reason. So if it's from that, if it's from,
Well, that's not a from.
we're switching on the from.
Oh, okay. And then
So it's from us. We just do that. Default. We check to see if it's the current ID in the list or not. And then if not. Now, in our particular case, though, this message is from us, right?
Yep.
So it's going to fall into this situation. And we always just wrote it.
Mm-hmm.
So now this is where we need to look at the two. Okay.
Yeah. And then get current item.
So this is where we care about the fact that if message 2, I need to know the current item in the list, right?
Yeah, so it would be that.
And that's just a string, so that's why we got to do hex. So that should solve our problem.
Because now.
Because it was from us, we sent it,
Yep.
but we only want to put it on the screen if the current person matches who we were sending it to.
Got it. Okay.
So I'm going to push this code. Hold on. We can test it because I'm going to switch over to Mohammed.
Yeah.
And we're going to play that game, but get commit -am. Fixing send, fixing UI, send bug. All right, so let's push that. You don't even need that latest one, but so I'm going to stay on Mohammed and send a message. Yeah. Oh.
No. Well, now it says you, but
I know, but it got written there, and it should have gotten written.
It's still called the button handler.
Well, all that's fine, right? It should have ended up in here, and we should have ended up in here. So I might do the following.
I would add, yeah, something that we can.
Okay, so just finished AI response, right? Put that in there. And I'll just do this as a hack.
Yep.
Right? So I should see that before the other thing, but hold on. Okay, I'm staying on Delaney. So that's good. Just finished response to, is that your eight? Is that your? Go check your file.
Let's see here. Let's see. Data. What was it?
E84. No, you're EC27.
It's
so
Delaney is that one. Current selected item is Delaney.
Oh, so that's
which
right.
is right.
So that's right. That's totally right.
But if they don't match, we don't want to write it. Which we are message.
I know, I want to see that. Oh, if it.
No, that.
No, only if it matches.
Only if it matches, we want to write
let's
it.
do it again, and I'll put that there.
Okay.
So the current is what I've got selected, and the 2 is should have been your ID, right? Okay, let's try it again. So I have Delaney here. So
Yeah, it's
we've
Delaney,
got a bug
Delaney.
on the, and I should have been sending it to you,
What
right?
is it? Because it's message to hex.
No. So my guess is we've got a bug on the, I might be assuming that, remember the UI might always be assuming that whoever was selected is who it's supposed to be going to. But you
Yes.
got the response. You got my response, right?
No.
Ah, so
No.
we're routing it to whoever's selected, not whoever brought the message in.
Exactly.
So that's the bug. Okay. So this will fix the problem once we're there.
Yes.
But
In agent response, I think it needs to know.
the problem is going to be here.
Or button.
You see, we're only looking at the currently selected item. That's the problem.
It needs to be whoever, for AI agent mode, it needs to be whoever.
Yes, it has to be who got us involved here. So when we're in agent response, we know who it was from.
Mm-hmm.
Okay, this is the from. Okay. Okay, this is the from. So when we call button handler,
Button handler needs to know who it was from.
and we need to use that from.
It took away the parentheses up there.
It's trying to help me when it shouldn't be. Okay, so this is who the message was from. That's who it's going to. Right? On this side, we can call it to. It's going to them. Okay, so everywhere we call the button handler, we've got to specify who we're sending it to. In this case, we're sending it to the person that
it's from.
That it's from, right? In this case, oh, this is an interface problem, so we're going to fix that. But in this case, The 2 is that other code we had, isn't it? Yeah, because I hit enter. So hold on a second.
So that would be who's currently selected.
Yeah, I want this code back without. I need this code. I need all this. Okay. We're going to fix the interface in a second, but
and then that goes to, yeah, okay.
okay. And then we got interface issues because from an interface perspective now, which I think is up. No, not here. Let's come back. Actually, it may not even be an interface. It could just be. Oh, this comes from. Oh, G-view. Okay, no big deal. It needs a function, so we're gonna have to wrap this function. Didn't mean to do that.
Oops.
Func. It wants to call the button handler. We'll have to do this. So that means that when we're going to need this code, by the way. You see, there's going to be cases where we call it without a from, and we're going to have to look it up.
Oh, okay.
Okay. And now what we're going to do is this. If 2
is empty.
How did we always do that? I don't need you, I need you. If 2 is empty, then ID. Something like that.
Got it. Okay.
That's interesting. You can put parentheses around that and check it. I didn't know that. That I didn't know. Because I've been trying to do that, but I've been having to compare strings, right? So anywhere that I'm doing like a compare.
Current ID.
No, that's already a string, so that one's fine.
That was a string.
And that was a string. So I guess this is the first time
we're doing it directly with a address.
So, oops, button handler. So now what we do is that if that's empty, we'll pull it from here. Else, we'll just use whatever's passed in, right?
Yep.
All right, let's try it now.
Okay.
And this has been going to the wrong person, so that sucks. Okay, I didn't see anything.
I got a response.
You got a response.
And it's there.
Okay.
Worked.
All right, I just did that wrong. But let's make sure that I can even send a message. Cool, dude. When you got it.
Got it.
Okay. All right, so just for now.
And if you have me selected.
Wait. Oh. Bug with the UI and sending this to, yeah, because now, you know, when you're in this AI mode, it can be sending messages on your behalf. You don't even
everywhere.
know. Okay.
Like if you have me selected. Yeah. Okay.
Okay.
There we go.
Damn, dude. All that's freaking working.
Nice.
Okay. So we now fixed our encryption bug by just breaking the message up into these 240. Mohammed just sent me a message. Let's see. Not much. Oh yeah, but it already sent him. But I could type now too, right? And
Yeah.
that. But we're gonna go back and update our notes now. But we should be able to turn that on and off.
Very cool.
Okay. So I'm gonna shut everything down right now. Always make sure nothing's running. Let's go and look at our notes now. Ooh, oh yeah, this is always going to be the case.
Exactly.
You're going to hate that. Let's just disable this again. Okay. So our data star is definitely broken now because we don't know how to write code in Templ. So that's a bummer. We're going to have to figure that out at some point. It's not my highest priority though. Okay, good news is we fixed this. And now we understand it. It can't be longer than the key. So I think what we did was good, even though we broke everything. We got to delete all the history.
It was a pretty big change.
It was, but it pretty much worked out of the box. But that introduced the fact that we always assumed that the user sent messages to the person that was selected. So we fixed that.
Yep.
Okay, so I think the next thing to do here is create some artificial delay. I think we do this first. So on Thursday, I think we do this.
Yep.
We add a UI to turn on and off. We could do LLM conversations, but we got to think more about response and then question. And we're going to need we need the turn it on and off so it would stop.
Yeah, because of that, it'll just...
So I think on Thursday we'll do that. And then I think what we're going to do after that is work on this. So we can bypass NATs if we've got a socket connection directly to the other cat. Okay. Yeah. And then there's some technical stuff there, which is good. Then once we have the ability to have cap-to-cap communication, I can call some people over at Tailscale and ask them how we could potentially use their tech to create the mesh of caps that are now, able to identify who they are and they talk to each other. And then once we've got all that, these other things sort of play in. So, but let me save these notes. So git commit -im. Saving notes. The cool thing, dude, is we're now able to do full encryption messages. We've broken them up. We've got the UI, at least the console UI. If you want to play again, and you don't have time right now, but
yeah,
if somebody wants to work on the data star and fix it, that will be good. Mohammed will be back on Thursday because I'm not traveling anymore. And we're going to finish all this AI agent mode stuff. I was really hoping to be able to run Olama in Docker Compose, so we just had a one-up. But I won't find my GPU, so we won't be able to do that. But I think we've sort of laid out exactly what I want to do. And Mohammed, thanks for your help as always. That was good. We had a little fun hacking.
Yep.
Yeah, I think that's it. So we will see everybody again on Thursday.